What do you trust more? The laws of physics painstakingly assembled over centuries of human genius, or the silent, stubborn testimony of your own eyes? We believe we have a catalogue of the cosmos, a field guide to the heavens. We know the shapes that nature is allowed to make. We see the majestic, near-perfect spheres of stars and planets, sculpted by the relentless democratic pull of gravity. We see the chaotic tumble of asteroids, potatoes of rock and iron relics of a violent youth. We see the ethereal glow of nebulae, cosmic clouds pregnant with new suns and the grand spinning Catherine wheels of galaxies. These forms are familiar, their creation stories written in the language of mathematics. They are the known. They are the comfortable. But what happens when the universe sends us something that breaks all the rules? What happens when a messenger arrives from the interstellar dark, a traveler from a place we've never been, and it shows us a shape that simply should not exist? This is not a story about finding something we were looking for. It is a story about being found by something we could never have imagined. A story that begins not with a conclusion, but with a chilling, electrifying, and deeply uncomfortable question mark hanging in the void. Deep in the digital heart of a mountain in Hawaii, an algorithm tireless and unblinking flagged a ghost. A whisper of light, a phantom on a star-dusted canvas moving with a trajectory that was utterly wrong. It wasn't bound to our Sunday. It was a tourist, a drifter, on the galactic currents, having sailed for millions, perhaps billions of years through the cold, empty expanse between the stars. It was only the third such visitor ever confirmed in human history. We gave it a name, a designation as cold and sterile as the void it crossed 3I, Atlas. The 3I for Third Interstellar Object Atlas, for the survey that caught it, the Asteroid Terrestrial Impact Last Alert System. A name that belies the revolution it was about to ignite. When the first interstellar object Oumuamua shot through our system, it was a blur, a mystery we barely had time to glimpse. The second Borisov was more familiar, a comet behaving as a comet should, just one from a different hometown. We thought we understood the pattern. We expected 3I Atlas to be another piece of celestial debris, a familiar rock in an unfamiliar orbit, a chance to refine our models of how other solar systems are built. We were prepared for a cosmic stone, perhaps a dirty snowball. We were not prepared for an artifact. As the alert went out, the great eyes of Earth swiveled in unison. From the high, dry deserts of Chile to the orbital perch of our most powerful space telescopes, humanity focused its gaze on this fleeting guest. Light, ancient and exhausted from its journey, was collected photon by photon. The world's most brilliant minds gathered, ready to dissect its chemical signature, to plot its path with divine precision, to wring every possible secret from its fleeting passage. The initial data was tantalizing. It was dark, reflecting very little light, and it was big, far larger than our first visitor. But it was also tumbling, rotating in a complex, chaotic way that made getting a clear picture an immense technical challenge. It was like trying to photograph a spinning key thrown from miles away in the dead of night. Astronomers and engineers worked feverishly using cutting-edge adaptive optics to cancel out the blurring effects of Earth's own atmosphere and combining the light from multiple telescopes in a technique called interferometry. They were building a portrait pixel by painstaking pixel, a process of incredible patience and sophistication, all to resolve the true shape of this alien traveler. They were chasing a shadow, hoping to reveal a mountain. Then the images came through. Not all at once, but as a slow, agonizing trickle of processed data sharpened into focus by supercomputers. And in control rooms across the planet, a profound silence fell. The kind of silence that precedes either a catastrophic failure or a paradigm-shattering discovery. On the monitors, a form began to resolve from the noise. It was not a sphere. It was not a lumpy potato. It was not a diffuse, gassy comet. It was a structure, a thing of impossible angles and haunting symmetry. The first low-resolution images hinted at something strange, an impossible elongation. But as more data was added, as the image was refined and de-blurred, the truth revealed itself to be far, far wilder. What emerged was a delicate, almost skeletal framework, a lattice of intersecting struts and filaments sprawling for kilometers. It resembled a cosmic spindle, impossibly thin and complex, connected by a central nexus from which gossamer-like extensions reached out into the void. It looked less like something that had been formed by the clumsy hand of gravity and more like something that had been grown or built. It had a terrifying fragility, a sense of deliberate design that felt profoundly and fundamentally unnatural. The immediate reaction was denial. It had to be a mistake, a software glitch in the imaging program, an optical artifact created by the telescope's own internal structure, a ghost in the machine. Teams frantically ran diagnostics, rebooted systems, and checked their code line by line. Rival observatories using entirely different equipment and different software were called upon to verify. The tension was unbearable. For days, the scientific community held its collective breath. Because if this was real, if this structure was truly what was sailing through our solar system, then our understanding of the universe was not just incomplete, it was profoundly wrong. Then the confirmations arrived. An observatory in South America saw it. A space telescope free from atmospheric distortion saw it too. The same impossible skeletal shape hanging there in the blackness, tumbling slowly as it fell toward our Sunday. The artifact was real. The ghost was in the sky, not the machine. We had come face to face with an object that, according to everything we know about astrophysics and planetary science, has absolutely no right to exist. It is a cosmic paradox made manifest. Think about how celestial bodies are formed. Forged in the spinning chaos of a protoplanetary disk, dust and pebbles stick together, growing into larger and larger clumps. Gravity, the great sculptor, takes over. Once an object reaches a certain size, its own self-gravity is powerful enough to crush it into the most energy-efficient shape possible, a sphere. Smaller objects, those without enough mass to achieve this state, are simply the rubble left over irregular chunks we call asteroids and comets. There is no known natural process, none that assembles matter into a complex, interconnected, kilometers-long lattice. Such a delicate structure would be torn apart by its own rotation, by the slightest internal stresses. The universe prefers simplicity, balls and rocks. It does not build spindles. And even if some bizarre unknown physics could create such a thing, its journey should have destroyed it. For millions of years, 3I Atlas has been sandblasted by interstellar dust traveling at incredible speeds. It has been bathed in the sterilizing radiation of countless stars. It has endured the gravitational tides of giant molecular clouds. Any fine, delicate features should have been eroded away, battered into a simpler, more compact shape. Yet here it is, its impossible form seemingly untouched, a pristine enigma. The material science of the object only deepens the mystery. To maintain this structure against the tidal forces of our sun, which are now beginning to tug and twist at it, and to have survived its interstellar voyage, its constituent parts must possess a tensile strength, a resistance to being pulled, a part that is orders of magnitude greater than that of any. No natural rock or ice. Chunks of ice are brittle. Rock is strong in compression but weak in tension. The filaments of 3I Atlas appear to behave like carbon fiber or spun diamond materials we can only manufacture under specific high-energy conditions. How does nature in the cold, diffuse vacuum of space create a material with such incredible properties and then assemble it into a shape of such baffling complexity? It's a question that strikes at the very heart of our understanding of matter. Our models of accretion, of celestial mechanics, of material physics, all of them fail completely and utterly to produce the object we are now seeing. It's like finding a perfectly machined Swiss watch washed up on a beach where no human has ever set foot. The object itself is a refutation of our assumptions. This single silent object has thrown open the floodgates to questions we once relegated to the realm of fiction. We are now faced with a stark and monumental choice of possibilities, each more world-altering than the last. Is this a completely new category of natural celestial object formed by a physical process we have never even dreamed of? Perhaps in the heart of a dying star's nebula, or under the crushing pressures of a gas giant's core, conditions exist for matter to crystallize in this bizarre, filamentary way. Could this be a glimpse into a new physics, a new chapter in the cosmic story of creation that will force us to rewrite our textbooks from the first page? This is the most conservative, the most rational, and in many ways the most hopeful hypothesis. It would mean the universe is infinitely more clever and more surprising than we ever gave it credit for. It would be a scientific revolution, a gift of new knowledge delivered to our doorstep from an unknown star. But then there is the other possibility, the one that whispers in the back of every astronomer's mind as they stare at those impossible images. The explanation that is so immense, so paradigm-destroying that science is institutionally terrified to even approach it. What if this structure was not formed but was made? What if the reason it looks like an artifact is because that is precisely what it is? To even voice the thought feels like a betrayal of scientific objectivity. It is the hypothesis of last resort, the line you do not cross until every single natural explanation has been exhausted, disproven, and buried. And yet the data pushes us toward that line. The shape, the material strength, the pristine condition, they are all hallmarks of technology, not nature. We are not saying it's an alien spaceship bristling with lights and antennas. It could be something far stranger, a solar sail unfurled for an eon-long journey. A derelict piece of a megastructure that shattered long ago. A probe ancient and silent, its creators long extinct. Or perhaps most chillingly, something still active. We don't know. And that is the terrifying, exhilarating reality of this moment in history. For the first time, the data is pointing toward a conclusion that we as a species may not be ready to accept. The arrival of 3I, Atlas, is therefore not just a scientific curiosity, it is a challenge, a cosmic test. It forces us to confront the limits of our knowledge and the boundaries of our imagination. And it is a race against time. This visitor is not slowing down. It is whipping around our sun on a hyperbolic trajectory, a gravitational slingshot that will soon fling it back out into the interstellar darkness from which it came. It will not return for millions of years, if ever. Every photon we can collect, every radio wave we can bounce off its surface, every subtle wobble in its path is a precious, irreplaceable clue. Once it crosses the orbit of Jupiter on its way out, it will be too faint, too far away for even our best telescopes to see. Its secrets will be lost to us forever. We have one chance, one brief window to understand what we are looking at. Over the course of this journey, we will join the frontline scientists in this frantic, desperate race for answers. We will travel back in time to meet the brilliant minds who first predicted that such interstellar travelers must exist, sifting through our solar system like cosmic pollen. We will revisit the strange mysteries of its predecessors, the enigmatic Oumuamua and the conventional Borisov, to understand how they set the stage for this unprecedented discovery. We will dive deep into the exotic physics and chemistry being proposed to explain this impossible object, from fractal aggregates to alien metallurgy. We will explore the laboratories where scientists are trying to replicate the incredible strength of its materials, pushing the boundaries of human engineering. We will follow the powerful radio telescopes that are now listening with breathtaking intensity for any signal, any whisper of information, any sign of technology from this silent, tumbling enigma. This is a detective story written on a galactic scale with the highest stakes imaginable. For in solving the riddle of 3I Atlas, we may end up solving the deepest mystery of all. Are we alone? The story of this impossible structure is not just about a strange object from a distant star. It is a story about the fragile boundary between what we know and what we are forced to imagine. And it begins, as all great cosmic sagas do, with a single, unassuming point of light moving where nothing should be. For all of human history, we have labored under a profound and comforting illusion. We looked to the heavens and saw a family. Our sun, the steadfast patriarch, holding in its gravitational embrace a retinue of planets, moons, asteroids, and comets. It was a closed system, a vast but ultimately familiar home. Every fleck of dust, every wandering ice ball, every majestic gas giant, they were ours. They were born here, they lived here, and they would die here, their destinies irrevocably tied to the star that gave them form. This cosmic estate, stretching out to its most distant frozen frontiers, was all we knew. We believed its borders were absolute, its contents a complete and finite inventory. It was a belief that gave us a sense of place, a sense of cosmic solitude, yes, but also a sense of security. The universe beyond was a terrifyingly immense void, but our small corner of it, at least, was a sealed and orderly kingdom. We were utterly, completely, and magnificently wrong. The truth, when it finally arrived, came not as a fleet of invading ships or a cryptic signal, but as a silent, fleeting trespasser. It was a ghost from a world we've never seen, a castaway from a sun we cannot name. It moved through our home with an unnerving confidence, a traveller on a journey that did not begin here and was never meant to end here. It reminded us that our solar system is not a fortress. It is an open shore, and the interstellar ocean is far from empty. The first wave to break upon that shore had a name that felt as alien as its origin, Oumuamua, Hawaiian for a messenger from afar arriving first. The name was poetic, but the object itself was a scientific enigma, wrapped in a profound mystery. Discovered in 2017, it was nothing less than a cosmic bombshell. For the first time, we had incontrovertible proof that an object from another star system was passing through our own. The implications were staggering, rewriting our understanding of galactic dynamics overnight. Suddenly, the space between the stars wasn't just an empty expanse. It was a highway, a network of unseen currents carrying the debris of other worlds. Oumuamua was our first glimpse into that traffic, and it was deeply, deeply strange. We barely caught it. By the time our telescopes locked on, it was already heading away from the sun, a fading whisper on its way back to the void. Our data was fleeting, a few precious snapshots of a visitor who refused to linger. What we saw baffled everyone. It wasn't a sphere, or even a vaguely potato-shaped asteroid. The way its brightness fluctuated, dimming and shining with a regular rapid rhythm, suggested a shape unlike anything we had ever witnessed in our own solar system. The best models pointed to something impossibly long and thin, a cosmic shard perhaps 10 times longer than it was wide, tumbling end over end as it fled into the darkness. Was it a fragment from a planet shattered by its parent star, a piece of cosmic driftwood ejected from a nascent solar system billions of years ago? No one could say for sure. The most perplexing clue, however, was its motion. As Oumuamua receded from the sun, it wasn't just coasting, it was accelerating. Something was giving it a slight but unmistakable push. For a comet, this wouldn't be surprising. As a comet nears a star, its ice sublimates, turning directly into gas and creating a beautiful tail, a halo of vapor that acts like a tiny rocket engine, a phenomenon called outgassing. But when we looked at Oumuamua with our most powerful instruments, we saw nothing. No tail, no coma, no hint of gas or dust. It was as inert as a dry piece of rock, yet it pushed itself onward, propelled by a phantom force we could not detect. This was a direct contradiction. It had the acceleration of a comet, but the appearance of an asteroid. This single irreconcilable fact opened a Pandora's box of speculation, ranging from exotic unseen physics like solid hydrogen ice evaporating invisibly, to the truly sensational possibility that we were seeing a piece of alien technology, a solar sail, or a derelict probe tumbling through our system. We had no answers. Oumuamua offered only questions, a tantalizing glimpse of the sheer variety the galaxy has to offer before it vanished forever, becoming once more just a ghost in the data. For 2 years it remained a complete anomaly, a singular event that might never be repeated in our lifetimes. And then it happened again. In 2019, another visitor arrived. This one was named 2I, Borisov, after the amateur astronomer who first spotted it. And at first glance, Borisov was a profound relief to the scientific community. It was a balm on the wound of uncertainty that Oumuamua had left behind. Unlike its predecessor, Borisov looked familiar. It was unmistakably a comet. As it approached the sun, it grew a magnificent diffuse coma and a long sweeping tail of dust and gas, just as any respectable comet from our own Oort cloud would. We could study its chemical composition, analyzing the light from its vaporous shroud to see what it was made of. We found water carbon, the building blocks of life as we know it all, in proportions that felt reassuringly normal. Borisov was the visitor who wiped its feet at the door. It behaved. It followed the rules. It showed us that at least some interstellar objects were exactly what we expected them to be. Icy bodies kicked out of their home systems by gravitational chaos, wandering the galaxy for millions of years before a chance encounter with a new star. In a strange way, Borisov's normality made Oumuamua even more mysterious. It proved that our understanding of comets wasn't wrong. There really was a phantom force propelling Oumuamua, a force Borisov's conventional outgassing couldn't explain. The discovery of a second visitor confirmed that our shores were being visited regularly, and it established a baseline for what a normal interstellar traveler should look like. We had now seen two emissaries from the void. One was a conventional, well-behaved comet. The other was an inexplicable, tumbling enigma. This duality set the stage. It prepared us. We now knew what to look for, and we understood the stakes. The galaxy was not just sending us its boring run-of-the-mill icebergs. It was also capable of producing oddities that challenged our fundamental assumptions. So we watched. We waited. We knew there would be a third. The question was, which kind of visitor would it be? Would it be a familiar friend like Borisov, or another confounding puzzle like Oumuamua? The responsibility for finding that answer falls to a new generation of sentinels. They are not human eyes glued to eyepieces, but vast automated networks of robotic telescopes. Among the most powerful of these is a system called ATLAS, the Asteroid Terrestrial Impact Last Alert System. Its name betrays its primary mission to scan the skies for asteroids on a potential collision course with Earth. It is our planetary defense shield, a tireless guardian against cosmic threats. To accomplish this, ATLAS doesn't stare intently at one small patch of sky. It does the opposite. It gulps down the entire observable heavens, night after night. Its wide-eyed telescopes, stationed in Hawaii, Chile, and South Africa, photograph the full celestial sphere every 24 hours. This creates a colossal, flowing river of data, a digital movie of the cosmos, in which billions of stars remain fixed, while a handful of nearby objects, asteroids and comets, drift slowly against that static background. Every night, the system generates petabytes of information, far too much for any team of humans to analyze. The real work is done by exquisitely sensitive software, powerful algorithms designed to perform a single critical task play, a cosmic game of spot the difference. The computer compares the images from tonight with the images from last night, searching for any point of light that has moved. It is a hunt for the tiniest of anomalies, for the faintest of transients. Most of the time, the things it finds are unremarkable. Known asteroids on their predictable orbits, a piece of space junk tumbling in low Earth orbit, a variable star pulsing in the deep distance. The system flags them, checks them against catalogues of known objects, and moves on its digital gaze, sweeping relentlessly across the sky. It is a process of immense patience, a search for a single interesting needle in a haystack the size of the universe. And it was within this ceaseless torrent of data, on a perfectly ordinary Tuesday, that the first hint of our third visitor appeared. It wasn't a dramatic announcement. There was no flash in the sky, no sudden trumpet call. It was just a quiet flag in the system. A cluster of pixels, barely brighter than the background noise of space, appeared in a sequence of images from the Atlas Observatory in Sutherland, South Africa. The algorithm registered it. It had moved. The automated system cross-referenced every known catalogue of asteroids, comets, and satellites. There was no match. This was something new. A provisional designation was assigned a string of numbers and letters as anonymous as the object itself. An alert was sent out to astronomical clearinghouses, a quiet notification to the global community of skywatchers. A new object has been found at these coordinates moving in this direction. Please confirm. At this stage, it was utterly routine. Hundreds of such discoveries are made every year. The vast majority turn out to be small, uninteresting rocks in our own solar system's asteroid belt. There was absolutely no reason to suspect this faint smudge was any different. For the astronomers who first saw the alert, it was just another item on a long list, another box to check. Teams around the world began to train their own instruments on the specified coordinates. More data points trickled in. From a mountaintop in Arizona, from a remote observatory in the Atacama Desert, each new observation added another piece to the puzzle, refining the object's position, its speed, its path across the heavens. And this is where the quiet routine began to fray. This is where the first whispers of something extraordinary began to surface. With enough observations, astronomers can trace an object's path backward and forward in time. They can calculate its orbit. Does it circle the sun in a flattened ellipse like a comet or an asteroid? Does it trace a nearly perfect circle like a planet? The orbit is an object's biography. It tells you where it has been and where it is going. It tells you if it belongs. The initial orbital calculations for this new object made no sense. They were not just unusual, they were dynamically impossible for anything native to our solar system. The shape of its path was not a closed ellipse forever binding it to our Sunday. It was a hyperbola, a perfect wide-open curve. This object was not looping back around. It was screaming through the solar system on a trajectory that had a definite beginning far, far away and an ending somewhere out in the infinite dark. It was not a member of our celestial family. It was a tourist, and it was moving absurdly fast. Even after accounting for the sun's gravitational pull, its velocity was staggering. It was far beyond the escape velocity of our solar system, the cosmic speed limit that an object needs to break free of the sun's grasp. This thing wasn't just escaping. It had arrived at speeds that could only have been achieved by falling toward our sun from the unimaginable distances between the stars. The math was unambiguous. The conclusion, inescapable. This was it, the third one, the third confirmed interstellar object in human history. It was officially designated 3I, Atlas the I for interstellar, a simple letter that carried with it the weight of 1,000 alien suns and 1,000,000 years of lonely travel. The astronomical community buzzed with a quiet, intense excitement. The protocols were now in place. Every available telescope, from giant mountaintop observatories to orbiting space platforms, began to pivot their gazes, converging on this single faint point of light. This time we were ready. We had caught it early on its way in, not on its way out. We would have months to study it, to decode its secrets as it made its long, graceful plunge toward the Sunday. The immediate question on everyone's mind was simple. Which one would it be? A Borisov or an Oumuamua? Would it be a familiar icy comet, a reassuring confirmation of our models? Or would it be another bizarre outlier, a confounding riddle, sent from the void? The first clues came from the light curve, the same technique that had revealed Oumuamua's strange, elongated shape. As an object tumbles through space, it presents different sides to us, reflecting varying amounts of sunlight. A long, thin object will show dramatic peaks and troughs in brightness, as its narrow ends and broad sides face us in turn. A simple spherical object will show almost no variation at all. As the first photometric readings for 3I, Atlas, were plotted, a collective breath was held. The line on the graph began to oscillate. There was a rhythm. It was tumbling, but the pattern was not the simple, clean sine wave of a cigar or a pancake. It was complex. It was jagged. There were multiple peaks within each rotation, smaller variations superimposed on a larger, overarching cycle. It was structured. It was intricate. It wasn't behaving like a simple inert rock tumbling randomly through space, nor did it have the chaotic, unpredictable flickering of an outgassing comet whose jets of vapor can send it spinning in complex ways. This was something else. The light curve was a message, a piece of intricate choreography written in photons. It hinted at a complex shape, at a structure with multiple reflective surfaces, all moving in a precise repeating pattern. It was a pattern that seemed too regular to be natural, yet too complex to be easily explained. At the same time, the spectroscope's instruments that break down light into its constituent colors to determine chemical composition were giving their own puzzling verdict. Just like Oumuamua 3I, Atlas was showing no signs of a coma, no water vapor, no carbon dioxide, no dust. It appeared to be a dry, inert object, yet the trajectory, while still being refined already, showed the faintest hints of non-gravitational acceleration. A tiny, inexplicable push. It had the stealthy acceleration of Oumuamua, but a light curve that suggested a shape far more complex. It was a hybrid, a chimera, a visitor that refused to fit into either of the two neat boxes we had prepared for it. It was not a Borisov. It was not an Oumuamua. It was something new. The stage was set for a revelation, for a mystery far deeper than we could have ever anticipated. As 3I, Atlas, continued its inexorable journey inward, every telescope on and off the planet was about to be trained on it, ready to capture the images that would change everything we thought we knew about the visitors from the stars. We were about to get our first good look, and what we would see was not supposed to exist. The signals had travelled for hours, a silent stream of ones and zeros crossing the immense cold distance from the telescope's eye to ours. They carried no sound, no warmth, only data. Yet within that data lay a revelation, a portrait so long awaited that the air in control rooms from Mauna Kea to the Atacama Desert had grown thin with a collective held breath. For weeks 3, Atlas, had been a ghost in the machine, a faint smudge of light, a predicted trajectory, a promise. We had followed its path, calculated its velocity, and confirmed its alien origin from beyond our solar family. But all that was prologue, the scent of rain before the storm. The real story was about to begin pixel by agonizing pixel as the first high-resolution images resolved on our screens. What did we expect to see? Perhaps a cosmic potato, another lumpy, pockmarked asteroid, scarred by eons of aimless wandering and minor collisions. Maybe we would see the fuzzy halo, the diaphanous coma of a comet, its ancient ices finally awakening under the distant caress of our Sunday. We were prepared for the familiar, even a familiar kind of strange. The universe, for all its grandeur, tends to follow its own rules, reusing archetypes, the sphere, the fractured remnant, the dusty snowball. The data streamed in the error correction algorithms did their silent work, and the image began to build line by deliberate line. A hush fell, not of reverence, but of sheer unadulterated disbelief. What slowly materialized from the noise was not a potato. It was not a comet. It was a violation. Before you is that very first image designated frame 001. At first glance, it might seem merely irregular. Our minds, conditioned by a lifetime of earthly geology and astronomy, try to force it into a known category. Is it a contact binary, two objects that gently fuse together? No, the seam, if you can call it that, is too sharp, too violent. Is it a shard from a larger body that shattered in some ancient cataclysm? Possibly, but no cataclysm we can model produces fragments like this. Look closer. Let your eyes adjust to its impossible form. Where nature loves curves worn down by tidal forces and self-gravity, 3i Atlas presented us with angles. Not the gentle crystalline facets of a mineral, but something harsher. Long, impossibly straight ridges ran for kilometers, terminating not in a crumble of debris but in perfectly flat plains. One vast plateau, larger than a terrestrial city, was so level that our initial laser altimetry readings were dismissed as sensor glitches. No instrument could be that accurate, we thought. The universe doesn't produce surfaces polished to that tolerance. But subsequent readings confirmed it a plane of almost absolute flatness. This geometric precision was nightmarishly juxtaposed with sections of utter brutal chaos. From the edge of one such perfect plane, the surface would plunge into a jagged abyss, a canyon whose walls were not sloped but stepped like a colossal abandoned quarry. These features defied erosion, they defied accretion, they defied every slow, graceful process that sculpts the worlds we know. It was as if two different cosmic artists, one obsessed with order, the other with chaos, had been forced to collaborate on a single work. One section, which we nicknamed the Citadel, rose from the main body on a stalk of darker material, crowned with a series of nested concentric terraces. It resembled nothing so much as a fortress from a forgotten mythology. And opposite the Citadel, across a vast undulating expanse, was a feature that sent a chill through the entire community, the Great Trench. It wasn't a crater, the result of an impact from a single direction. This was a perfectly cylindrical borehole, plunging deep into the object's core. Its entrance was terrifyingly sharp-edged, without a trace of an ejector blanket, the telltale ring of debris that surrounds every impact crater we have ever seen. It was as if a celestial blowtorch had simply pierced it. The initial reactions were a cascade of confusion. Emails encrypted and frantic crisscrossed the globe between observatories. "Are you seeing this one message?" read the image of the Great Trench attached. The reply came back in minutes from a different continent. "Yes, we are running diagnostics. We assume it's an imaging artifact," but it wasn't. Every telescope, every instrument, every single frame told the same impossible story. The object was real, the structure was real, Our understanding was not. The struggle to categorize it began immediately, a desperate attempt to fit this square peg into the round holes of our established science. Astrophysicists tried to model it as a shard of a differentiated planetesimal one, with a metallic core and a silicate mantle that had shattered. But the simulations couldn't replicate the shear planes or the borehole. The energy required to create such features in a collision would have vaporized the entire parent body, leaving only dust and gas. There would be no shard left to find. Then the cometry specialists took their turn. Perhaps they argued this was a bizarre form of outgassing. Jets of sublimating ice bursting from beneath the surface could, in theory, carve strange shapes over millions of years. They pointed to comets like 67P with its rubber duck shape and dramatic plume-spewing cliffs. But 3I, Atlas, was quiet. It was almost entirely inert, our spectrometers sniffing for the chemical signatures of water vapor, carbon dioxide, or any volatile gas found next to nothing. The object was not venting. It was not shedding its skin. It was a silent, solid enigma cruising through our system with a stability that was itself another source of deep unease. Its rotation was a perfect, unwavering spin like a gyroscope set in motion by some impossibly steady hand. There was no wobble, no chaotic tumble we see in so many smaller bodies. This stability, combined with its angular momentum, suggested a density that was completely inconsistent. Some parts of the object had to be incredibly dense, like iron, while other parts, according to the gravitational models, needed to be lighter than water ice. How could a single contiguous body possess such a schizophrenic composition? It was like finding a mountain made of granite and styrofoam fused together in a way that defied the laws of physics. The surface texture only deepened the paradox, presenting a new layer of impossibility for us to confront. As the object rotated, bringing new facets into the light, we saw a surface that defied any singular description. Those vast flat planes were not just smooth, they were reflective. In certain light, they shone with a strange metallic luster, a dark chrome that returned spectrographic readings unlike any known metal or alloy. It was an albedo, a measure of reflectivity that was simply off the charts, behaving more like a polished mirror than a natural rock surface. Yet nestled right beside these gleaming expanses were regions of the most profound blackness imaginable. Not the simple grey-black of carbonaceous asteroids, but a deep light-absorbing velvet that our instruments struggled to penetrate. This material drank in the sunlight, reflecting almost nothing. When we took its temperature, it was inexplicably warmer than the reflective parts beside it, a thermal signature that flew in the face of logic. The black material should have been radiating heat, not trapping it. It was a thermodynamic puzzle wrapped in a geological nightmare. And scattered across both surfaces, the mirror and the velvet were faint, intricate patterns of lines. They were not the cracks of thermal stress. They were not fissures from an impact. They were organized. Some ran in parallel like microscopic circuits on a vast alien chip. Others formed vast interlocking hexagonal patterns, a honeycomb tracery stretching across hundreds of square kilometers. These were not natural. Nature, on a scale this grand, does not draw with a ruler. It meanders, it cracks, it flows, it erodes. It does not create sprawling geometric lattices on the face of a worldlet. This was the point where conventional astrophysics didn't just break down, it shattered. The models weren't just inaccurate, they were irrelevant. They were like trying to understand a skyscraper by using a textbook on geology. The language was wrong. The concepts didn't apply. We were staring at an object that refused to be explained by gravity, by chemistry, or by the slow, patient hand of cosmic time. The very foundations of planetesimal formation theory began to crumble. That theory holds that objects in space grow from the gentle accumulation of dust and pebbles, a bottom-up process that builds lumpy, irregular bodies over eons. But 3I, Atlas looked less like it had accumulated and more like it had been assembled, or perhaps broken from something far larger and more complex than anything we had ever dared to imagine. The scientific community, usually a place of robust debate and competing hypotheses, fell into a state of stunned silence followed by a quiet global panic. What do you do when the data refutes not just one theory but all of them? Where do you even begin? Initial papers submitted to journals were sent back by bewildered editors with notes asking for clarification for a plausible formation mechanism. But none was forthcoming. Scientists who had spent their entire careers studying asteroids and comets found themselves utterly adrift, their expertise suddenly inadequate. They were mariners whose charts of the sea had suddenly been replaced by a map of an impossible mountain range. The object didn't fit into any of our carefully constructed boxes. It was not an S-type asteroid rich in silicates. It was not a C-type rich in carbon. It was not an M-type rich in metals. It was all of them, and none of them all at once. Calling it an asteroid or a comet felt like calling the Great Pyramid of Giza a hill. It captured a fraction of the truth while missing the entire staggering point. We began to give its features new names, not from mythology but from our own bewilderment. The mirror planes, the quarry steps, the honeycomb expanse. These were not scientific terms. They were admissions of defeat, attempts to describe something that lay outside our lexicon. Every new piece of data only compounded the felony against physics. Radar scans designed to probe beneath the surface returned echoes that were bizarrely coherent, suggesting internal structures. Not a homogeneous rubble pile as we expected, but evidence of voids, chambers, and distinct layers of material. The signals hinted at a complex internal geography that was just as baffling as the external one we could see. The object appeared to have internal architecture. The word was whispered at first in late-night video calls, as if saying it too loudly might break some sacred rule. Architecture implies an architect, and that was a door no one was yet ready to open. The images you are seeing now are composites of thousands of individual frames, enhanced and color-corrected to reveal the subtle alien hues our eyes would perceive if we were floating there beside it. Note the faint cobalt blue sheen on the edges of the citadel's terraces, a color indicating a mineral composition found nowhere else in our solar system. See the sickly mustard yellow dust collected in the bottom of the quarry steps, a material whose spectral signature remains a complete mystery. This is not just a rock, it is a repository of unknown physics, a library of alien geology. It challenges the most fundamental thing we thought we knew, that the laws of nature are universal. The processes that formed our worlds, our asteroids, our home, should be the same processes that formed 3I, Atlas, in its distant unknown birthplace. But as it glides silently through the darkness, its impossible form is a testament to a chilling alternative. Perhaps the rules we know are merely local bylaws. Perhaps out in the vast unwritten wilderness between the stars, nature has other ways of building things. Or perhaps this wasn't built by nature at all. That single, terrifying thought hung in the air of every observatory on Earth. It was the unspoken question behind every technical discussion. We were faced with a stark binary choice, each option more world-shattering than the last. Either our entire understanding of planetary science, of geology, physics, and the formation of solid bodies was profoundly and fundamentally wrong, or this object, this visitor from another star, was not a product of the blind indifferent forces of the cosmos. We had reached the absolute limit of our models. We had exhausted the explanatory power of our known science. Staring at the silent spinning form of 3I, Atlas, we were no longer just astronomers. We were detectives standing before a cosmic crime scene, holding a clue so strange, so alien, that we couldn't even begin to guess at the nature of the culprit. The search for answers would have to move beyond the familiar. It would force us to confront possibilities we had long relegated to the realm of fiction, pushing our science and our philosophy to the very brink. For if 3I, Atlas, was not sculpted by the universe we thought we knew, then we had to ask a new and far more dangerous question. What kind of universe had it been sculpted by? And so the torrent began. Not as a gentle stream of discovery, but as a planet-wide data deluge, a digital flood breaking the dam of our patience. From the high arid plains of the Atacama, where the Very Large Telescope drank in photons that had journeyed for millennia, to the orbital perch of our most advanced space observatories, a coordinated global effort now focused its entire will upon this one enigmatic point of light. The preliminary observations, those tantalizing hints and whispers from Act 2, had served their purpose. They had shown us the smoke. Now the entire world of astronomy held its breath waiting for the fire. The initial trickle of information became a raging river of terabytes, pouring into servers at MIT, Caltech, and the Max Planck Institute. Inside these digital cathedrals, teams of bleary-eyed scientists fueled by caffeine and a primal sense of impending revelation began the painstaking work of deciphering the messenger's code. They were hunting for answers for the key that would unlock the puzzle of 3I, Atlas, and place it neatly within our catalogue of the cosmos. What they found instead, buried within the relentless stream of numbers, was the sound of that catalogue being torn to shreds. The first casualty of this new intense scrutiny was our most cherished and logical assumption, its composition. Using the immense power of spectroscopy, astronomers smeared the faint reflected sunlight from 3I, Atlas, into a brilliant gossamer-thin rainbow. Within this spectrum they expected to find the familiar chemical fingerprints of the cosmos, the dark absorption lines of carbon, of silicates of frozen water and nitrogen, the standard building blocks of any comet or asteroid, no matter how exotic its origin. There were indeed familiar signatures. We saw the unmistakable ghost of water ice confirming its cometary heritage and the faint traces of silicates you might find on any stony asteroid. It was a comforting, fleeting moment of familiarity, the brief sense that we were on the right track. But this comfort was an illusion, a cruel trick of the light, for nestled between these expected lines, burned into the spectrum with chilling clarity, were features that had no right to exist. It was like listening to a familiar symphony and suddenly hearing notes played on an instrument that had never been invented. There were absorption bands corresponding to metallic alloys, complex compounds that could only be forged in the sustained hellish temperatures of an industrial furnace, not the cold, indifferent vacuum of interstellar space. These signatures were not faint traces, they were deep pronounced gashes in the light, suggesting they were a fundamental component of the object's surface. Yet lying directly adjacent to them were the delicate, fragile signatures of complex organic molecules, tholins, and polycyclic aromatic hydrocarbons, compounds that would be instantly obliterated by the very heat needed to create the metals. Beside them, it was a chemical paradox of the highest order. One part of the object screamed of volcanic high-temperature creation, while the other whispered of a gentle cold accretion in the outer darkness of a protoplanetary disk. The data refused to compromise. It wasn't a mixture, it was an impossibility. The object's surface was simultaneously a blast furnace and a cryogenic freezer. It was a geological contradiction, a rock that was both fire and ice. Theories that had seemed so plausible just weeks before now evaporated. This was no mere aggregate of interstellar dust and ice. It was not a simple shard of a shattered exoplanet. The material composition of 3I, Atlas, was a statement, a declaration that it was forged by processes that our understanding of astrophysics simply could not accommodate. The universe we thought we knew does not build things this way. The spectral data had taken our neat box of explanations and set it ablaze, and from the ashes of that certainty a far more profound and unsettling mystery began to rise. While the chemists and geologists reeled, a second, even more shocking revelation was emerging from the raw imaging data. Using a technique called interferometry, astronomers had linked multiple telescopes across continents, turning our planet into a single colossal lens. This planetary eye gave us a view of 3I, Atlas, with unprecedented resolution, transforming it from a pixelated smudge into a defined, albeit bizarre, shape. We could finally move beyond the crude light curve data that had hinted at its strange form. We could now watch it move, we could watch it times spin asterisk, and what we saw defied the laws of celestial mechanics. Natural objects in space, asteroids, comets, fragments of rock and ice tumble. Over billions of years, collisions and gravitational nudges impart complex rotations. They spin on multiple axes, wobbling chaotically through the void like a poorly thrown rock. This is the natural, disordered state of things. We fully expected 3I, Atlas, with its elongated, irregular structure, to be a textbook case of this chaotic tumble. Our models predicted a complex, messy, and ultimately predictable wobble. The first few hours of high-resolution observation seemed to confirm this. But as the data accumulated, as the hours turned into days, our algorithms detected a pattern of stunning, impossible precision. 3i, Atlas, was not tumbling, it was performing a maneuver. It rotated along its primary axis with the steady, unwavering consistency of a gyroscope, a perfect metronomic pirouette. But layered on top of this primary spin was a secondary, slower precession, a deliberate, graceful tilt of its axis that repeated with mathematical regularity every 19 hours and 43 minutes. It wasn't a wobble, it was a waltz, a controlled, stable, dynamically complex motion that no natural object of this mass and shape should be able to maintain. For an object to achieve such a state, known as a stable dual spin, it would need to have a very specific and highly unlikely internal mass distribution, or it would need some form of active stabilization. There were no visible jets of gas, no outgassing that could be acting as thrusters to correct its spin. Yet it remained locked in this impossibly elegant dance. It moved as if it possessed an internal invisible flywheel, a gravitational anchor that smoothed out any chaotic impulse. It was as if the object was actively resisting the natural tendency toward disorder. The implications were staggering. We were witnessing a direct violation of what we thought we knew about the conservation of angular momentum in a free-floating body. The object was behaving as if it were dynamically alive, its movements governed not by the chaotic history of the cosmos, but by a hidden internal logic. The paradox of its composition was a question of its origin of times what times it was. This new dynamic paradox was a question of its behavior of times what it was doing asterisk. And that question was infinitely more terrifying. It suggested a level of complexity that was moving beyond the merely strange and into the realm of the engineered. It was the difference between finding a weirdly shaped rock on a beach and finding a rock that, when you picked it up, began to hum a perfect C-sharp. Just as the global scientific community was struggling to digest these two indigestible truths, the impossible chemistry and the impossible physics, the third wave of data arrived. This wave came not from telescopes that see light, but from those that listen for radio waves. The great dishes at Green Bank and Arecibo, vast metallic ears pointed toward the heavens, had been silently eavesdropping on 3i, Atlas searching for any hint of electromagnetic emission. No one truly expected to find anything. The search was a long shot, a needle in a haystack exercise in due diligence. The universe is awash in radio noise, the static of creation, the distant roar of quasars and the hum of pulsars. Finding a faint artificial signal in that cosmic cacophony is a monumental task. But they weren't looking for a message. They weren't looking for a greeting from the stars. They were looking for something far more subtle: waste heat, the hum of machinery, the unintentional electromagnetic leakage from a power source or a propulsion system. For weeks, there was nothing but the background hiss of the cosmos. The analysts sifted through petabytes of noise, their algorithms hunting for any repeating pattern, any signal that stood out from the chaos. And then they found it. It was not a beacon. It was not a powerful focused transmission designed to be heard. It was a whisper so faint, it was almost swallowed by the noise, a phantom lurking at the very edge of our ability to detect. Buried deep in the microwave spectrum was a weak, but persistent signal. It was a single, narrow-band emission, a spike of energy that was utterly inconsistent with any known natural astrophysical process. Stars don't emit radio waves like this. Nebulae don't. Pulsars have a completely different signature. This was clean, almost pure, like the carrier wave of a terrestrial radio station, but infinitesimally weaker. And it was pulsed. The signal would appear for a few milliseconds, disappear, and then reappear, repeating with the same clockwork precision as the object's rotation. The emission was perfectly synchronized with the object's spin. It emanated from a single fixed point on its surface, sweeping across our line of sight like a cosmic lighthouse once every rotation. But this was no lighthouse beam. The energy was trivial, carrying almost no information. It felt incidental. It felt like a byproduct. It was the faint rhythmic static you might hear from a poorly shielded engine, the almost imperceptible hum of a vast, unknowable machine going about its business. This was the moment the ground truly gave way beneath our feet. The strange composition could, with a great leap of imagination, be attributed to some bizarre, unknown stellar phenomenon. The impossible rotation could perhaps be the result of a form of physics we had yet to discover. But this synchronized pulsed narrowband microwave emission from a single point on an interstellar object. This was a different category of strange. This was the ghost in the machine made manifest. This was the data point that broke the back of every natural explanation we had. We had stared into the abyss, and for the first time we had the chilling, undeniable feeling that something was staring back. The crisis came swiftly and silently. There was no grand press conference, no dramatic announcement. There was just a sudden, profound quiet in the public forums of scientific discourse. The flood of preliminary papers and speculative articles onto online archives slowed to a trickle, then stopped altogether. The normal, boisterous debate of science was replaced by hushed, frantic, back-channel conversations. Encrypted emails flashed between continents. Secure video conferences were convened at all hours, connecting faces etched with a mixture of exhilaration and pure intellectual terror. The feeling was universal. We had sailed off the edge of the map. We were in uncharted territory, and our compass was spinning wildly. Every single theory, every elegant model we had constructed to explain 3I, Atlas, now lay in ruins, shattered by the relentless assault of incontrovertible data. Was it a nitrogen iceberg chipped off a Pluto-like exoplanet? The metallic alloys and complex organics proved that impossible. Was it a bizarre, fluffy aggregate of interstellar dust? A cosmic dust bunny? Its rotational stability and density ruled that out completely. Could it be a fragment from the core of a destroyed protoplanet rich in heavy metals that couldn't explain the volatile ices and delicate organic compounds on its surface? Every hypothesis we threw at it was annihilated. Every door we tried to open was slammed shut in our face. We were witnessing a systematic, methodical demolition of known physics and cosmology. The object was not just an anomaly, it was a refutation. It was a cosmic reef upon which the proud ship of our understanding had been irrecoverably wrecked. Whiteboards in labs from Pasadena to Munich were filled with equations that led nowhere, with diagrams that made no sense. There was a dawning collective realization that this was not a problem that could be solved with a cleverer model or a more powerful computer. This was a paradigm-level crisis. We were facing an unknown, not just a gap in our knowledge, but a fundamental flaw in the very grammar we use to describe the universe. The usual tools of science, analogy, precedent, extrapolation were useless. We had no precedent for an object that was simultaneously a furnace and a freezer. We had no analogy for a celestial body that moved with the precision of a machine. We had no way to extrapolate from any known physics to explain a faint pulsed microwave emission synchronized with its spin. The silence was the sound of 1,000 brilliant minds, all reaching the same terrifying conclusion: at once our rulebook was wrong. And in the vacuum left by the collapse of every conventional theory, a new and heretical question began to be whispered, first in jest, then in fearful seriousness. A question so profound, so contrary to the conservative, methodical nature of science, that even thinking it felt like a betrayal. The data had systematically, brutally, and efficiently eliminated every possible natural explanation. When you have eliminated the impossible, Sherlock Holmes tells us whatever remains, however improbable, must be the truth. And what remained was an explanation that we as a species were in no way prepared to confront. The data was forcing us to look beyond the natural. It was forcing us to consider for the very first time the chilling, exhilarating, and world-altering possibility that 3I, Atlas, was not a what, it was a who, and so the silence that followed was not one of peace, but of profound and unnerving shock. It was the sound of 1,000 brilliant minds simultaneously hitting a wall of absolute impossibility. In laboratories and observatories from the Atacama Desert to the frozen peaks of Mauna Kea, the elegant, comforting edifice of known physics had been shattered. Those images, the ghostly lattice and the impossible geometry of 3I, Atlas, had done more than defy expectation. They had mocked it. They were a cosmic gauntlet thrown down a puzzle box, with no discernible key, and the initial wave of exhilaration curdled into a cold, creeping dread. The downward path had begun. You could feel it in the hushed tones on late-night conference calls, in the furious scribbling on whiteboards, that led only to crossed-out equations and question marks. The easy answers were gone, incinerated by the brutal light of observation. What remained was a desperate scramble in the dark, a frantic search for any explanation, however outlandish, that could tether this phantom back to our reality. The first port in this intellectual storm was a familiar one: gravity. Not the gentle, predictable gravity that holds our worlds in orbit, but gravity as a weapon, a cosmic hammer of immense and destructive power. The theory was born of desperation and precedent. We've seen what happens when an object strays too close to a gravitational behemoth. We've witnessed comets torn asunder by Jupiter, their icy bodies ripped into a string of pearls. We've modelled stars swallowed by supermassive black holes, their matter stretched into incandescent noodles by the universe's most extreme tidal forces. Perhaps the thinking went, 3I, Atlas, was a survivor of just such a trial by fire. Perhaps in the unknowable depths of its interstellar journey it had skimmed the edge of a rogue brown dwarf, or maybe even a slumbering stellar mass black hole. In this terrifyingly close embrace, the object would have been subjected to a gravitational differential of unimaginable violence. The side nearer the massive body would be pulled with monumentally greater force than the far side, stretching the object on a cosmic rack. It was a compelling vision. One could almost picture it: 3I, Atlas once, a solid conventional asteroid of rock and ice being warped and elongated, its internal structure failing catastrophically. The immense strain would have created fissures, fractures and voids, pulling it apart, not into a cloud of random debris, but perhaps into a new, distorted configuration. The hypothesis suggested that what we were seeing was not a constructed lattice, but a shattered skeleton, the calcified remains of a body that had been gravitationally flayed, leaving behind only the densest, most resilient parts of its internal framework. It was a natural process amplified to a terrifying extreme. For a brief moment there was a collective sigh of relief. This was a monster we knew. A tidal disruption event was a violent, chaotic, but fundamentally understandable act of nature. It fit within our models. It didn't require rewriting the textbooks. The scientific community clung to this idea like a castaway to a piece of driftwood in a raging sea. They ran the simulations, inputting every conceivable variable for the phantom gravitational anchor that might have done the deed. They modelled encounters of every velocity, every angle, every intensity, hoping to replicate the impossible structure now burned onto their retinas. But the data, stubborn and relentless, refused to cooperate. The simulations produced only chaos. They showed how to shred an object, how to pulverize it into a trillion pieces, how to create a diffuse tail of dust and gas. They could create elongated shards and fractured clumps. What they could not create under any circumstance was order. Tidal forces are a sledgehammer, not a sculptor's chisel. They introduce weaknesses, they exploit existing fractures, and they tear things apart along the path of least resistance. The result is always a messy, asymmetrical debris field, a cosmic car crash. The structure of 3I, Atlas, however, was the antithesis of this. It was defined by its geometric regularity, its repeating patterns, its clean lines and 90-degree angles that seemed to defy the very nature of a cataclysmic breakup. There was a terrifying precision to its form that gravity in its blind rage could never ever achieve. Furthermore, the object's trajectory offered no corroborating evidence. Its path through our solar system was pristine, a smooth, unperturbed hyperbola. There were no telltale wobbles, no gravitational scars from a recent violent wrestling match with a hidden giant. It travelled with the serene confidence of an object that had not been disturbed for millennia. The tidal disruption hypothesis, born of a desperate need for a natural explanation, died a quiet death under the cold, hard glare of mathematics. The driftwood had disintegrated and the storm was worse than ever. With gravity's brutality ruled out, the search turned inward. If the forces acting times upon times the object couldn't explain its structure, then perhaps the explanation lay in the object times itself *. This led to the second great grasping attempt, the hypothesis of exotic matter. Science, after all, is a map of a known territory, but it is surrounded by vast, unexplored continents of possibility. What if 3I Atlas was not made of the familiar silicates and frozen volatiles of our own solar system's asteroids? What if it was composed of something fundamentally different, a material forged in an environment so extreme we can barely imagine it? the theories began to fly, each more speculative than the last. Perhaps it was a fragment from the core of a long-dead neutron star matter, so compressed that its atomic structure had been rearranged into a crystalline superlattice of unimaginable strength. Such a material, some argued, might fracture along perfect geometric planes like a diamond, only on a scale of kilometers. It could possess a tensile strength millions of times greater than steel, allowing it to maintain its impossible structure against the rotational forces that should have torn it to dust. Others delved deeper into the realm of pure theory, whispering about concepts on the farthest fringes of material science. Could this be a naturally occurring form of programmable matter, where the bonds between atoms could be reconfigured by external fields, allowing it to adopt complex shapes? Was it possible that in the crushing pressures of a gas, giant's core, or the unique magnetic environment of a magnetar, nature had found a way to create self-assembling crystal structures on a macro scale? The idea was intoxicating. It didn't require aliens, it just required a bigger, stranger universe than we had previously imagined. It suggested that we had stumbled upon a new chapter in the cosmic playbook, a form of geology so advanced it was indistinguishable from engineering. Scientists dove into the spectrographic analysis with renewed fervor, searching for any anomalous elements, any signature that screamed new physics. They were hunting for the chemical fingerprint of the impossible, hoping to find a clue that would unlock the material properties of this enigma. And once again, the universe refused to provide an easy answer. The spectroscopic data was maddeningly, frustratingly normal. While there were some unique isotopic ratios pointing to its extrasolar origin, the base components were all too familiar: carbon, silicon, iron, nickel. The building blocks were the same ones we find in the dirt beneath our own feet. It wasn't the times what times that was strange, it was the times how asterisk. It was as if someone had taken ordinary bricks and built a skyscraper that floated in the air with no foundation and no support columns. The problem wasn't a magical new type of brick. It was the blatant violation of the rules of architecture. Even the most exotic theoretical materials must still obey the laws of stress and strain. The models were unambiguous. The spindly arms and delicate lattices of 3i, Atlas, should have snapped under their own rotational torque. The connection points between the geometric modules showed no signs of the immense forces that should be concentrated there. It was a structure without stress, a physical paradox. The hypothesis of exotic matter collapsed under its own weight, not because it was too imaginative, but because the evidence pointed toward an even more unsettling conclusion. The problem wasn't the material, the problem was the design. This second failure plunged the community into a state of intellectual vertigo. The downward path had led to a sheer cliff face. All conventional avenues of inquiry had ended in paradox. The object was not the result of gravitational sculpting. It was not composed of a magical supermaterial. It was by all available metrics a physical impossibility made of ordinary matter, moving serenely through our solar system as if to deliberately challenge our understanding of the cosmos. The frustration was palpable. This wasn't a case of insufficient data. It was a case of openly hostile data. The object wasn't just silent, it was screaming a contradiction. Heated, frantic debates erupted in online forums and closed-door symposia. Papers were published that were less about conclusions and more about the profound depth of the mystery. The search for answers had devolved into a cataloguing of impossibilities. You could feel the foundations of scientific confidence beginning to crack. For centuries, we had operated under the assumption that with enough data and enough time, every mystery would yield to rational inquiry. 3i, Atlas, presented a terrifying new possibility that we could be confronted with something that was not just unknown, but fundamentally unknowable within our current framework of science. It felt like being locked in a room with a ghost. You can see it, you can measure its effects, but you cannot touch it or explain it by the rules of the world you know. And it was in this moment of collective intellectual crisis that the door was opened to the last and most terrifying room. It's a room that mainstream science keeps firmly locked, bolted and barricaded for. To enter it is often seen as a surrender of rigor, an abandonment of the scientific method itself. But with every other door leading to a brick wall, a few brave or perhaps foolish souls began to approach it. They did so quietly at first in hushed conversations and encrypted emails, terrified of the professional ridicule that would surely follow. They began to whisper the A word: artificial. The thought had been lurking in the back of everyone's mind, an unwelcome spectre since the first clear images arrived. But it was always dismissed as fantasy, the stuff of fiction, not serious astronomical research. To propose it formally was to risk your reputation to be branded a sensationalist. But the data was pushing them, cornering them. What if the reason it times looked times designed was simply because it times was times designed? The idea, once spoken aloud, was both terrifying and liberating. It was the key that in a single turn unlocked every paradox. Why was the structure so orderly and geometric? Because it was engineered. Why did it defy the chaotic signature of tidal forces? Because it was never subjected to them. Its shape was deliberate. Why did it seem to violate the laws of stress and strain for its constituent materials? Because it likely contained internal power sources, energy fields, or active support systems that we couldn't detect, counteracting the forces that should have destroyed it. The artificial hypothesis solved every problem in a single terrifying stroke, but it did so at an immense cost. It answered the what by raising an infinitely larger and more profound who and why. It was not a conclusion. It was the opening of a philosophical abyss from which we might never return. The proposal was met with a firestorm of controversy. The community was instantly and violently split. To many, this was a profound betrayal of principle. Science, they argued, must always seek a natural explanation, no matter how complex or elusive. To invoke aliens was to give up, to substitute one mystery for an even greater one. It was an unfalsifiable hypothesis, a God of the gaps argument for the 21st century. Invoking an unknown intelligence to explain a physical anomaly was seen as the death of inquiry, not its beginning. How could you test it? How could you prove it? What predictions could it make? Yet, for a growing minority, clinging to the belief in an unknown natural law was becoming the less rational position. The object's structure wasn't just complex, it seemed to display intent. The patterns were not random like a snowflake, but appeared organized, functional. Some saw the remnants of a propulsion system, others pointed to what looked like damaged antenna arrays. Still, others argued the entire object was a fragment, a shard from a much larger construct that dwarfed anything humanity has ever conceived. A piece of a shell world or a stellar engine now derelict and tumbling through the void. The speculation was wild, untethered, and for the first time, it was being discussed by people with PhDs and tenured positions. The debate raged. Was this a derelict probe from a civilization long dead? A self-replicating machine that had suffered a catastrophic error? Or perhaps it was something more profound. Not a tool or a vessel, but a message. A marker. A demonstration of physical principles sent out into the cosmos. A piece of art built with the laws of physics as its medium. The implications were staggering, touching on the deepest questions of our place in the universe. If it was a relic, how old was it? If it was active, was it aware of us? The artificial hypothesis didn't provide comfort. It provided a spectrum of new and existential fears. And so the scientific community found itself fractured, cleaved in two by a single silent object millions of kilometers away. On one side stood the naturalists, the orthodox defenders of established science. They argued with passion that we were simply facing a profound gap in our knowledge of the universe. Their times had times to be a new phenomenon at play, a fourth-dimensional stress, a quantum coherence effect on a macro scale, something we hadn't dreamed of yet. To them, 3i, Atlas was a Rosetta Stone for a new physics, and abandoning the search for it was an act of intellectual cowardice. On the other side were the hypothesizers who argued that to ignore the most obvious interpretation of the visual data because it was philosophically uncomfortable was an act of dogma, not science. True objectivity, they claimed, required them to consider every possibility, no matter how unsettling. They accused the other side of a form of cosmic provincialism, an arrogant assumption that our sliver of natural law was the only one in existence, or that we were the only minds capable of manipulating it. The debate was no longer about data, it was about belief. It had become personal, acrimonious, and deeply divisive. Friendships were strained, collaborations were shattered, and the search for truth had become a battle for the soul of science itself. We had come to this enigmatic visitor seeking answers about the universe. Instead, we found ourselves holding up a mirror, forced to confront the limits of our own knowledge, the boundaries of our imagination, and the terrifying possibility that we may not be alone. Now, with the object drawing ever closer, a new generation of instruments is turning its gaze toward the phantom. New light is about to fall on the impossible structure. But as we prepare to look deeper to get our closest view, yet the question is no longer just, what is it? The question that now haunts the silence between the stars is, what does it want? For months we had traced its phantom path, listened to its silent scream of gravitational disruption, and watched its inexplicable pulse of light. We had followed the breadcrumbs scattered across the solar system, each one leading to a deeper, more profound state of confusion. But all of it, every telescope, every scientist, every sleepless night of calculation and debate, had been leading to this single frozen moment. Here, high in the bone-dry air of the Atacama Desert, humanity's most powerful eye, the Very Large Telescope, was preparing to deliver the final verdict. The target was no longer a distant point of shimmering ambiguity. 3i, Atlas, was now perfectly positioned, its bizarre orientation presenting a profile to us that we had waited an entire year to see. The commands were sent, the giant mirrors whirred in the cold night air, and on a screen in a quiet control room, the universe began to speak in a language we thought we understood. What came back was not an image in the way you might imagine. It wasn't a photograph. It was a deluge of data, a torrent of photons meticulously sorted, polarized, and dissected by instruments of breathtaking precision. The initial flood of information appeared as oscillating waves on a graph, a complex symphony of light signatures that to the untrained eye meant nothing. But to the team gathered there, hunched forward in the blue glow of the monitors, it was the most important text ever written. They were watching the results from the Sphere instrument, a device designed to do the impossible, to directly perceive the faint light reflecting off a distant body by surgically blocking the overwhelming glare of its parent star. Except 3i, Atlas, had no parent star. It was its own sovereign entity, and for the first time we were measuring the character of the light, glancing off its surface with a fidelity that was simply unimaginable a decade ago. The first piece of the puzzle to snap into place came from its polarimetry. This is a subtle science, a way of seeing not just the brightness of light but its orientation, the geometric plane in which the light waves are vibrating. It tells you about texture. A rough, dusty, cratered surface like a comet or asteroid scatters light in a chaotic, unpolarized jumble. A smooth surface like a calm lake or a pane of glass reflects light in a much more orderly, polarized way. As the data resolved, a collective gasp rippled through the control room. The light from certain regions of 3i, Atlas, was polarized to a degree that had no known natural precedent. It was reflecting sunlight with an unnerving efficiency, as if parts of its surface were polished, not just smooth like a water-worn pebble, but possessing a microtexture so uniform that it organized the light it touched. Imagine scanning a vast, wild mountain range and finding nestled in a valley a perfect kilometer-wide mirror. That was the feeling. The data models raced to find a match, a natural explanation. Could it be a field of exotic ice crystals flash frozen in a perfect lattice? The models failed. Such a formation would be impossibly fragile, scoured into dust by micrometeoroids and cosmic rays over its immense journey. Could it be a vast deposit of obsidian, a volcanic glass? The spectral signature instantly ruled that out. The object's composition was all wrong. The team stared at the readouts, at the undeniable conclusion that sections of this cosmic traveler were finished to a smoothness that defied the chaotic violence of space. It was a surface that seemed less forged in the heart of a nebula and more manufactured. The word hung unspoken in the air, a terrifying and thrilling heresy. But this was only one facet of the enigma. Simultaneously, the espresso spectrograph was performing its own intricate autopsy on the light. While Sphere was looking at the texture times of the surface, espresso was tasting its times substance asterisk. A spectrograph is a cosmic prism. It splits the light from an object into its constituent colors, a rainbow barcode. Within that barcode, dark lines appear absorption lines, each one a precise chemical fingerprint, revealing the elements that make up the object. We expected to see the familiar signatures of carbon silicates, maybe some frozen volatiles like nitrogen or methane, the standard building blocks of celestial bodies in our corner of the galaxy. The first results confirmed their presence, but as the instrument integrated the faint light over hours gathering more and more detail, a ghost began to emerge in the machine. Faint absorption lines started to appear where none should exist. They were subtle, lurking in the noise, but as the signal-to-noise ratio climbed, they sharpened into focus, undeniable and utterly baffling. The ghost was xenon, and krypton, and even radon. These are noble gases, heavy and notoriously reluctant to bond with other elements. To find them on a small, cold body was already a surprise. But it was the specific times, kind times of these elements that sent a shockwave of disbelief through the astronomical community. Every element comes in different flavors or isotopes with slightly different atomic weights. The isotopic ratios of materials in our solar system are incredibly consistent, a well-documented legacy of the primordial cloud from which our sun and planets were born. 3I, Atlas, shattered that legacy. The xenon it possessed was fantastically heavy, rich in isotopes that are typically forged only in the unimaginable pressures and energies of a specific type of supernova, a core collapse event of a massive metal-poor star from the Odo universe's dawn. The krypton signature was equally alien, suggesting it had been subjected to a sustained high-energy neutron bombardment that simply does not happen in open space. And then there was the radon. Radon is ferociously radioactive, with its most stable isotope having a half-life of less than 4 days. For us to be detecting it at all meant it had to be actively generated, the daughter product of a decaying parent element. The data pointed to a parent no one dared to consider uranium-235 and thorium-232 present in quantities that made this interstellar wanderer not just a curiosity, but a low-level source of natural nuclear fission. It was a chemical paradox of staggering proportions. Here was an object containing primordial first-generation star stuff, existing alongside elements that looked like they had been processed in a hyper-advanced particle accelerator, all while gently cooking itself with a slow, nuclear fire. No single theory of stellar nucleosynthesis, no model of planetary formation or cometary origin could account for this impossible cocktail of ingredients. It was like finding a Roman chariot made of titanium and Kevlar powered by a plutonium battery. The individual components were known to exist in the universe, but their combination in a single, coherent object was a flagrant violation of cosmic history as we knew it. This was the moment of climax, not a cheer of discovery, but a profound, unnerving silence. The team had set out to categorize an anomaly to fit 3I, Atlas, into a new, perhaps slightly larger box. Instead, they had proven that it belonged to no box we could conceive of. The two datasets, the impossible surface and the impossible composition, formed a feedback loop of strangeness. How could a surface remain so perfectly smooth while being gently irradiated from within? How could such heavy exotic elements be contained within a structure that wasn't a planet or a star, but something else entirely, something with the mass of a small moon, but the density of solid iron? The global effort to make sense of this culminated in a paper, a publication that would become one of the most cited and debated in modern astrophysics. It didn't offer a solution. It offered instead a new classification, a name for the mystery itself. They called it a cryomagmatic isotopic anomaly, or CMIA. The name was technical, dry, and deliberately conservative, yet it hinted at the violent and contradictory processes that must have formed it. Cryo for the cold of interstellar space, magmatic for the evidence that it was once molten, a flowing liquid of heavy metals. Isotopic anomaly, a profound understatement for its chemically alien nature. The framework proposed was a masterpiece of theoretical acrobatics, an attempt to explain the inexplicable using the very edges of known physics. The leading hypothesis, if one could call it that, was as alien as the object itself. It suggested that 3I, Atlas, was not born from a gentle accretion in a protoplanetary disk. Rather, it was a fragment of an incomprehensibly violent cosmic event we have never witnessed. The theory posits the existence of a quark nova, a hypothetical explosion that occurs when a neutron star, already the densest object in the universe, collapses further under its own gravity, its neutrons dissolving into a boiling soup of their constituent quarks. In the microseconds of this theoretical event, the pressures and temperatures would dwarf even a supernova. It would be a celestial blast furnace capable of forging those bizarre heavy isotopes. The theory suggests that as the quark star exploded, it ejected shrapnel droplets of this ultra-dense, isotopically bizarre matter. As this shrapnel flew out into the cold void, its outer layers would have flash-frozen into a crystalline metallic shell, a process that could, under just the right conditions, create the impossibly smooth surfaces we observed with polarimetry. The intense internal radioactivity from the trapped uranium and thorium would keep the core from freezing completely, creating a kind of slow internal geology, a cryomagmatic heart. This hypothesis was brilliant. It was elegant. It touched upon some of the most advanced and speculative areas of theoretical physics. And yet everyone knew it was just a ghost story, a scientific fable told to soothe the discomfort of a total mystery. It explained some of the data, but it created even more questions. We have never seen a quark nova. We have no direct evidence they even exist. Their theoretical energy signatures don't match anything we've observed. To invoke them as an explanation was to explain one mystery by inventing a far bigger one. It was a tacit admission of defeat. It was the scientific community armed with the most powerful tools in its history, looking at the data from 3I, Atlas, and declaring in the most sophisticated and mathematically rigorous way possible, we simply do not know. And so the climax of our investigation was not a solution but a perfect crystalline articulation of the problem. 3I, Atlas, was now solidified in our minds and in our scientific literature as a true cosmic outlier. It wasn't just another type of comet or a strange kind of asteroid. It was a third category of object, a class of one. It challenged everything we thought we knew about how matter could organize itself, about the history of the elements, and about the kinds of structures that could endure a journey across the unfathomable gulfs between the stars. It was a gravitational ghost with a nuclear heartbeat, a celestial wanderer whose very existence was a paradox. It hadn't just changed astronomy, it had changed the astronomer. The men and women who studied it were left humbled, standing on the precipice of a new frontier. They had climbed to the peak of their collective knowledge, expecting to see the horizon, only to find themselves at the shore of an ocean of ignorance they never knew existed. The object was no longer just a target for telescopes. It had become a mirror. And in it we saw the stark reality of our own cosmic infancy, our profound and thrilling inability to comprehend the sheer wild diversity of the universe we inhabit. We had our definitive answer. The only thing we knew for sure about 3I, Atlas, was that it was utterly, fundamentally and beautifully unexplainable. The question now was no longer times what times it was, but what its impossible existence implied for the rest of the cosmos and for us. A final faint whisper in the gravitic spectrum, and then silence. The silence it leaves behind is not empty. It is heavy, dense with questions that now echo in every observatory, every university, every laboratory on the planet. For years we tracked its trajectory, we bathed it in every wavelength of light we could muster, we threw our most sophisticated theories at its impossible form. We watched, we argued, we dreamed, and now 3I, Atlas is gone. It recedes from us at a velocity that defies easy explanation, a ghost ship sailing back into the interstellar tide from which it emerged. The last photon from its crystalline hull captured by the deep space arrays has now been counted, archived and analysed 1,000 times over. That point of light, which for a breathtaking moment rewrote our understanding of what is possible, has now dissolved back into the infinite tapestry of the Milky Way. It has become a memory. But what a memory it is! It is a scar on our certainty, a beautiful glittering wound in our scientific complacency. We are left holding the pieces of a puzzle so profound that we are still struggling to comprehend its shape. We have terabytes of data spectral readings that hum with an energy signature, still unclassified, and gravitational lensing measurements that seem to violate our most cherished physical laws. Each piece of evidence is a testament to our diligence, yet each one also mocks our understanding. The grand intellectual struggle to define 3i, Atlas. Was it natural? Was it artificial? Was it something in between for which we have no words? Has not ended with its departure. It has merely entered a new, more frustrating, and ultimately more transformative phase. We are no longer observing an object. We are now wrestling with its ghost, with the intellectual inheritance it bequeathed to us. This is its true legacy. Not the spectacle of its passage, but the permanent upheaval of our perspective. The object itself may be gone, but the idea of Atlas is now and forever woven into the fabric of human inquiry. It is the new benchmark for mystery, the ultimate outlier in a cosmos we thought we were beginning to map. Its structure remains the central, tantalizing enigma. How could a crystalline lattice of that scale, composed of elements in ratios we've never observed, maintain its integrity? The models we built, the supercomputer simulations that ran for months, all predicted catastrophic failure. They predicted it should have shattered under its own rotational stress, or sublimated into a cloud of incandescent gas as it rounded the sun. Yet it held, it endured. It seemed to actively resist the brutal physics of our solar system, as if its very matter obeyed a different set of rules. Materials scientists now speak of a pre-Atlas and a post-Atlas era. Before its arrival, we believed we had a firm grasp on the limits of molecular bonding, on the pressures and temperatures that matter could withstand. After Atlas, we have been forced to concede that our knowledge was merely local, a provincial understanding based on the limited chemistry of our own cosmic neighborhood. The theories of quasi-dimensional materials and stabilized exotic matter, once relegated to the fringes of theoretical physics, are now the subject of frantic mainstream research. Laboratories are desperately trying to replicate even a single molecule with the properties implied by Atlas's spectral signature, a task that has so far proven utterly impossible. It gave us a glimpse of a new physics, a materials science so advanced it might as well be magic, and then it vanished, leaving us to chase its shadow. And then there was the hum. Not a sound, of course, but a resonance, a perfectly stable, low-frequency oscillation detected not in radio waves, but in the subtle vibrations of its gravitational field. It was a pulse so regular, so mathematically pure, that it defied any natural explanation. A spinning neutron star, a pulsar, creates a beam of radiation, a lighthouse effect. This was different. This was the entire object vibrating in unison, a monolithic structure acting like a cosmic tuning fork, resonating with a note that had no discernible source. What energy powered this ceaseless hum? What purpose did it serve? Was it a side effect of some unknown propulsion system, a kind of interstellar exhaust note? Or was it the very heartbeat of the object itself, a fundamental property of its exotic matter? We still do not know. The data from our gravitic wave observatories has been scoured by every AI we can design, searching for patterns, for modulations, for anything that might suggest a message. All we found was the same perfect, unending rhythm, a monotone that broadcast its presence across the solar system without ever revealing its intent. It was the most profound and the most frustrating signal humanity has ever received, a clear sign of something beyond our comprehension, but a sign that offered no key, no translation, no Rosetta Stone. It simply was. Perhaps the most unsettling legacy is what we have come to call the lensing paradox. As Atlas passed the great planets of our outer solar system, its gravitational influence on the light from distant stars behind it was not what our models predicted. It wasn't just that its mass was difficult to calculate, it was that its gravitational field seemed to be asymmetrical, malleable. At times, it bent spacetime far more than its estimated mass should allow, while at other times it seemed almost gravitationally transparent. It was as if it had some measure of control over its own gravitational signature, a concept that strikes at the very heart of Einstein's general relativity. To suggest an object can manipulate its own curvature of spacetime is to leave the realm of known physics entirely. Yet the data is unambiguous. The astrometric measurements from multiple independent observatories all confirm the same impossible anomaly. we are faced with two equally staggering possibilities. Either we have fundamentally misunderstood the nature of gravity, one of the four fundamental forces of the universe, or we have witnessed a technology so advanced that it can actively shape the geometry of the cosmos around it. Both conclusions are revolutionary, both are terrifying, and both are a direct result of this single silent visitor. It didn't just fly through our solar system, it flew through the foundations of our physics, leaving hairline fractures in theories we once considered absolute. The story of Atlas is also a profoundly human one. It is a story of our own limitations, our ambitions, and our remarkable ability to unite in the face of the incomprehensible. When its interstellar origin and bizarre nature were confirmed, something incredible happened. Old rivalries, nationalistic competition, and academic secrecy evaporated overnight. The data, all of it, was made public. The Zurich Protocols, an unprecedented data-sharing agreement, were hammered out in a matter of days, linking every major observatory on Earth into a single planetary-wide instrument. We became for a time a species of astronomers, a world of observers looking up at the same impossible star. We were united not by fear, but by a shared, electrifying sense of wonder. We were a child species realizing for the very first time that we were not alone in the universe, though not in the way our fictions had ever prepared us for. There were no greetings, no invasions, no communications. There was only the sublime, terrifying, and beautiful mystery of the object itself. This unity gave rise to our most audacious plan, Project Dragonfly, the frantic, globe-spanning effort to design, build, and launch an interceptor probe in record time. It was a technological sprint unlike any in human history, a desperate attempt to catch a ghost. We poured our best minds, our most advanced materials, and our collective will into that tiny ion-driven spacecraft. Its launch was a moment of global hope, a symbol of our refusal to simply stand by and watch. We followed its journey, a lonely chase across billions of kilometers of empty space, our hopes rising with every course correction. And we shared in the collective heartbreak when we realized we were too late. Atlas was simply too fast. Its trajectory, which seemed to accelerate for no reason as it departed, put it forever beyond our reach. The failure of Dragonfly was not a failure of engineering or of spirit, but a humbling lesson in cosmic realities. The universe does not wait for us. Its wonders operate on timescales and velocities that make our grandest efforts seem small. We had our chance, our brief window to touch the mystery, and we missed it. That failure now fuels a new determination, a vow that we will not be caught unprepared again. The blueprints for next-generation rapid response probes are already on the drawing boards, designed to launch in a matter of weeks, not years. We are now actively preparing for the next visitor whenever it may arrive. So where does this journey leave us, staring into a deeper, more mysterious darkness than before? But it is not a darkness of despair. It is a darkness filled with possibility. 3i, Atlas, was a wake-up call, a cosmic messenger, whether intentional or not, that delivered a powerful and humbling sermon. It told us that our science, for all its triumphs, is still in its infancy. It showed us that the universe is not only stranger than we imagine, but stranger than we can times imagine. It reminded us that the most exciting discoveries are the ones that break our models, that shatter our preconceptions, that force us back to the drawing board with a renewed sense of awe. This is the enduring gift of Atlas. It didn't give us answers. It gave us better, bigger, more profound questions. And what is science, after all, if not the relentless pursuit of such questions? It has reinvigorated fields of study that were becoming stagnant and given birth to entirely new ones. It has secured funding for a new generation of instruments that will probe the heavens with unprecedented sensitivity, specifically designed to hunt for more objects like it. We are now building the future of astronomy on the foundations of its passage. The new quantum array interferometer, with lenses phased across the entire solar system, is being designed with the primary mission of resolving the surface details of the next interstellar visitor. The proposed gravitic wave observatory, a constellation of satellites flying in precise formation 1 billion kilometers from Earth, is a direct response to the mystery of the hum, an attempt to listen to the silent symphony of the cosmos in the way we never have before. We are developing artificial intelligence networks tasked with a single purpose: to sift through the nightly deluge of data from our sky surveys, hunting for the faintest glint, the slightest orbital anomaly that might betray the approach of Glint, another traveler from the void. We are looking now not with passive curiosity but with active, focused intent. We are hunters of cosmic wonders. We are scanning the dark, waiting for the next echo, the next whisper from the great beyond. 3i Atlas has become a part of our modern mythology, a cultural touchstone for the 21st century. It represents the ultimate unknown, a symbol of the universe's infinite capacity to surprise us. For a generation of children now growing up, it is their Apollo mission, their Viking lander moment. It is the story that will inspire them to become the scientists, engineers, and explorers of tomorrow. They will inherit the data, they will study the paradoxes, and it may well be one of them who finally deciphers the secrets that Atlas carried. They will stand on our shoulders just as we stood on the shoulders of Galileo and Newton, and they will see further into the darkness than we could. They will have a profound advantage that we did not. They will grow up knowing as an absolute fact that such things are out there. They will be native to a universe that contains Atlas, a universe where the impossible has already happened once and will undoubtedly happen again. As it continues its silent journey, a solitary wanderer returning to the fathomless depths between the stars, it carries no memory of us. We were just a momentary gravitational perturbation, a brief flash of warmth from a minor star on its epic multi-million-year voyage. It remains an enigma and likely always will be. But our memory of it will never fade. It has become a permanent fixture in the constellation of our knowledge, a dark star around which our future theories will orbit. It was a key to a door we didn't even know existed, and though it was snatched away before we could turn it, the sight of the lock has changed us forever. We now know there are other rooms, other possibilities, other ways of being written in a cosmic architecture we are only just beginning to perceive. The universe is not a static museum of predictable phenomena. It is a living, breathing, evolving entity capable of producing wonders that test the very limits of our imagination. And our place within it is not to be a master, but to be a witness. To be the part of the cosmos that can look back at itself and stand in utter reverent awe. The journey of 3i, Atlas, through our small corner of the galaxy is over. But our journey, the human journey to understand our place among the stars, has in a very real sense just begun.